Welcome, and today's video is going to be a very casual video, nothing serious, just going to answer a few commonly asked questions that I've been getting over the last few weeks by my students. And the first question that's been absolutely on everyone's mind is, what is the deal with this bit on the side of my head? And there's no easy way to tell you guys, but it's my white hair. I'm going grey. Thank you very much for pointing that out. Second question that's been really on a lot of people's minds is, how old am I? Pretty old, but young enough to still be alive. I'll give you that much. Next question I've been getting a lot from students lately is, do I have a YouTube channel? The answer is yeah. Another question I've been getting a lot lately is, what's this thing on my computer? That is my drive, my external storage drive. I just lost the previous one last year, so it was a lot easier to keep track of it if I stuck it down to something. So I sticky taped it to my computer, and it also helps me sort of plug it in when I'm going around. So if I pick up my computer, it's still plugged in rather than having it dangling off the side of my bench. Next question is, am I making $1 million off of YouTube? And no, that's not true. In fact, I will screenshot you a snippet from my Google AdSense. So we've got YouTube, Google AdSense. They sort of talk to each other. YouTube tells Google AdSense how many minutes, how many ads, things like that. And Google AdSense sort of makes up a number, how much you get paid. So last year, I don't know, made about $200 in total, probably just enough to cover my coffee addiction. Actually, on that note, my year 7s, I've been challenging them to see how many observations they can make when you stir a freshly made cup of coffee. So here, what, you don't have a mug that has the periodic table of elements on it too? Pff, you're missing out. But the observation I was hoping that you guys would notice is that as you stir the freshly made hot cup of coffee, is that the sound that the coffee mug makes as your spoon strikes the edge changes sound. And you can sort of exaggerate this by taking the spoon out and giving it a bit of a tap. Did you notice the change in pitch? We'll go on more. And on that note, I think we've got to... Yeah, it tastes like coffee. Oh, wait. Yeah, it smells like coffee too. I better taste it one more time, just to be sure. That's good. Okay, moving on. So the curious thing is, what causes that change in pitch? I've had a few suggestions. I'm not going to agree to any of them, but there have been some suggestions. So some students were thinking that with your mug, as you stir it, so I got my spoon in here, as you stir it, you sort of make a vortex, and so the level of coffee sort of rises to the edge, and therefore that's what's creating the sound. So I'm curious, maybe you want to check and try and put this to the test. I believe it should still work with a hot cup of chocolate, a hot cup of, something like that. As long as it's hot liquid with something dissolved in milk, I think that will roughly do it. But yeah, I'm curious, like maybe if you stir it slower, or you might stir it in such a way that the coffee itself does not climb, and then see if it still makes the sound. Other people said that it might be to the temperature of the spoon. So as I take it out, maybe the temperature of the spoon is making a difference. So I encourage you, test it out. Take 2, maybe 3 identical spoons, one in the fridge, one in the freezer, one at room temperature, and maybe even one inside the cup itself, and see if you can repeat the experiment and see if they make a difference, the temperature of the spoon. But yeah, I'll leave that up to you. It's a curious thing. See if you can challenge yourself to investigate and listen and smell and taste for observations. Another thing that people have been asking is, oh yes, my year 9s are learning about nuclear radiation, and this is one of the things that popped up is that we talked about how aluminium, wood, and plastic were able to absorb beta radiation. So beta radiation is approximately the same thing as electrons flying through the air. I haven't known much more details than that. Most people will just abbreviate that in terms of all the textbooks I come across. But it's curious that I think it's due to So if I got an atom here with some electrons on the outside, the basic thing is that as the electrons approach, they can sort of slow down and change direction. And as they change direction, they've slowed down and they've lost energy from forward motion. So we know that energy and mass is conserved. And so if it's slowed down, then it has to have given its energy somewhere else. And its energy can be expressed, oh dear, as an X-ray, so a little wiggly line for an X-ray, which then can be absorbed by another electron, and then it absorbs it and releases it, and that excites another electron, which absorbs it and releases it. And as it goes down the line, the energy is dissipated across the atoms everywhere. I think there's a German word for this. I've forgotten what it's called, but I think that's one of the reasons why things get absorbed by beta decay. But why wood, why plastic, and why aluminium? These are all generally low atomic mass, low atomic number atoms. It seems that from my very, very brief reading that high atomic number or highly big, fat, heavy atoms, they don't absorb electrons very well. And I think it might be because when the atoms are small, that means few protons, therefore it's got few electrons, therefore it's a small atom overall. When they're small, they can approach a little bit closer towards the nucleus and therefore interact and slow down. However, if you've got a large, my computer's acting up, love Windows, but when the atom's much larger, the distance between the nucleus, which has the positives, and the electrons that are rather further away, if it's a bigger and bigger atom, that reduces the sort of hold on those outside electrons. So if you're bombarding it with another electron, it can actually kick off an electron from the outside of other existing atoms. And so you don't deal with the electron problem. It's sort of just swapping it for another electron that goes flying, which is another sort of, you could imagine as beta decay. So maybe that's something to do with it. If you know the answer, if you're an expert teacher, if you know a bit of physics out there, I know that some teachers out there on YouTube also watch my videos. If you know more about this, I would love to hear it. So if you could put some comments down below. And students, if you're curious, you can probably go investigate it and see if you can find that fancy German word I referred to earlier. Don't know what it's called. Something I like to address is the lack of videos this year so far. It's been my goal this year to make a lot more YouTube content. And I think you can sort of figure out why I was being sort of hitting a bit of a snag. Now, I was going to make some more math tutorials. However, this machine has been the most frustrating thing to work with, especially the software that decides to kick the bucket. And so I've spent hours and hours where none of the footage is usable because the tablet itself did not record the illustrations. Even right now, it's not playing very nicely. So that's what I've been up against. I'm not even sure if this recording is going to work. But until I figure out a solution, I think I might not be able to do very many videos with this tool. But fingers crossed. Hope I can figure it out, and I've changed the RAM allocation settings, and I'm going to try different software in the near future. That's it, guys. That's basically what I've been up to, answering a few questions. If you got more questions for me, drop them in the comments below. I'll see if I got time to answer them now. If I don't answer them in the YouTube comments, I will maybe put them in for the next vlog where I might answer your questions. All right, catch you guys later. Bye.